So I gave you a challenge last time, but we're not going to start with that. Right now, what we have is a working game or a working map with tiles that we can lay out, and we kind of have a stripe of tiles that I defined in a tiles.txt file. But we're actually not going to start with this episode because we're going to be creating something first that's going to allow us to test our map and test the code that we're about to create. And that's something that's even more important than that, and that is the main character. We're actually going to have a player in our game now, which is pretty awesome. We need one. We need something to actually move around and see what's going on. So, pretty exciting. We have a player. We can move around and stuff. Let's get this going. So, here's something we could do with everything that we have. Well, right now, you know how we have the render method and the update method, right? And that is in our game. We have update and we have render. Remember, render is what's called every time it possibly can. Update is called at a very specific amount of time. I think we having that being called, we have update called 60 frames per second. And that's how much update is called at a constant rate. So these are two methods, right? And what we could do is with every object we have, not just the player, but because we're gonna have, we might end up having a lot more. We could go through every one of them and say, okay, player.render, particles.render, you know, well, whatever we have, entity1.render, flower animations.render, you know, anything we could possibly have, mob1.render, mob2.render, chucktesta.render. I had to include that, I'm sorry. Yeah, we could do that, but there's something that logistically will make our lives easier, well, logistically can make our lives easier and just makes our code look a lot nicer. And that is using a hierarchy. And a hierarchy, well, Java is a hierarchy. You have object, which is everything in the entire Java, like anything ever that you have in Java is an object, and you can cast it to an object and do whatever you want with it. We have, you know, there's so many things you can do with Java as far as the hierarchy goes. You know, lists and stuff can be cast back to collections. You know, Java is all about hierarchy, and we want to continue continue with what Java is doing because hierarchy is very useful and leads to some great organization. So we're gonna bring back some interfaces. Now I forget if we ever did anything with interfaces throughout this series so far. This might be the first time, and if it is, I'll just give a quick rundown of what an interface is. An interface is kind of like extending a class, except you can't actually instantiate an interface because an interface just kind of tells us what we want. It tells us what we want, anything that implements the interface to have. I do think I talked about this at some other point in the series, but that could have been before episode. It could have been before lesson 4, where I kind of wanted most people to start. So, yeah, it's kind of like extending a class. You kind of implement interface. You implement an interface, and any voids that are defined within that, voids or methods or anything that are defined within that interface, will be implemented, and you have to use them. So, here's an interface for a game object. Now, this game object is going to represent any game object we have in our game. And this interface is only going to have two methods. That is public void render and public void update. And you might say, is this complete? Is this a complete class? Yes, this is complete. With interface, you never give any method a body. I'm not sure. Actually, in recent Java updates, they might have allowed you to add bodies to some methods, but we're not going to do that. We're just going to have this basic stuff inside the interface without defining the methods at all. And they will be defined in anything that implements this interface. In fact, you're forced to define every method in anything that implements this interface. Another cool thing about hierarchy, or this, what we can do with the hierarchy is you can have a field in game.java, which is just an array of game objects called objects. And in our constructor, we set that equal to the amount of objects we have. And in render, we loop through every one of those objects and render them in the order that they are in the array. So just from 0 all the way to the length of the array. So that's pretty awesome. It's like a hierarchy, and we're continuing with the great organization that Java has as a language, which is just great organization. So this is pretty easy to implement. Now let's just go to our workspace here and create a new class, and we're just going to call this class GameObject.java. Let's change that and open that up. So instead of saying public class, I'm going to say public interface because this is an interface called game object. And this is a method, well, we're going to have two methods, public void render and public void update. They're both voids, don't return anything. Render is called every time it's physically possible. I'll just kind of put these comments in there so we can remind ourselves what these two methods do. And we call that, well, we have 60 frames per second as the rate for update. Now, the only things that these two voids are going to take, for render, we need to take a render handler, which we've defined, and we also need the X zoom and Y zoom. Everything else will, we're hoping that the whatever implements this game object will be able to figure out. So, and update is just going to take an instance of the game.java. And you might be asking, why are we doing that? Well, to be honest, game object is a very simple class, right? And game object, well, a very simple interface, I should say. And we want to make sure that update is very powerful for how simple it is. Now, if you give something an instance of game, that's I mean, there's a lot of stuff you can get from this. You know, you can make any methods in here, getters and setters, to change anything in the game. So that's very useful to have. And some of you who are not as used to using Java might think, well, is this transferring all of the data of game? And that's not true. All this is doing is transferring a pointer. So pretty much it's transferring the memory address of game. So this really isn't that big of a deal. It's just something that's going to help with our different objects. So along with this, we want to go to game.java now, and we want to actually create that array list I was talking, or not array list, just an array of game objects. So we're just going to do that. Create another section here for this. So here's just going to be an array of game objects, and we're just going to call these objects because they are just the game objects. And then all I said was in our constructor, and we'll do this after we load map. We're going to load objects, and we're just going to set objects equal to new game object, and right now we have 0 objects. I'm just going to set that to a completely empty array. And then this is pretty simple. We actually don't have anything in update so far, but I know we're probably at some point going to use this. So we're going to go ahead and do for int I equals 0. We're just going to do the basic for loop here to loop through all of the objects. And we're just going to do objects I. Okay, so I'm going to get rid of these brackets because we only have one thing in this for loop. Objects of index, I'm going to do dot update. And remember, update only has one argument, one parameter in game object, and that is the instance of game. Now, right now we're writing this inside of game. So there's a very useful Java keyword you can use to pass a pointer to itself, a memory pointer to itself in Java, and that is this. So this pretty much represents this class in Java, and I'm pretty sure we use this at some point in constructors to set specific variables, maybe in Sprite. Yeah, in Sprite, since width and height were passed in via the constructor, and we had a width and height field, we had to get this dot width equal to width because we didn't want to just set width equal to width, because that would just set this variable equal to this variable, which we don't want. So yeah, we have done that before. So yeah, that's all we need in update. And then where we have this render.render and map.render, we want to keep those because those aren't really game objects. Those are just very big things that take very specific parameters. So we're going to keep those as is, and I guess right before the render.render, because that's what actually copies the pixels and stuff. We're just going to go through all of the game objects like we did up there. I wonder if I could just copy. Yeah, I'll just copy this. All we need to do is change the method we're calling. So we're just going through all the objects, and the method we are calling, I'm just going to copy this over and paste that. Oh, yeah, paste that here. So it's render, and all it does is take a renderer, the X zoom and the Y zoom, which I think we defined. We did define in here, did we? Maybe we didn't. Okay. Then we'll just pass in 3 and 3 because that's what we're saying our map zoom is. So, yeah, we might make fields. It's probably best to make fields for that at some point. I'm not going to worry about that right now. Anyway, let's make sure everything compiles. Oh, we do have an error. There's 62. What is this? Oh, map.java. Oh, no, that's why I never actually finished this off. So we're gonna go ahead and comment this off, because we haven't done anything with that yet. Map.java 58 cannot find symbol fill tile ID. All right, let's comment this whole thing off because I don't want to worry about that right now. Game object cannot find symbol render handler, not renderer handler. All right, cool. So all of those stupid spelling mistakes and stuff is fixed. And yeah, it runs, but we are not actually doing anything with this yet. So that's pretty cool. Now we have some game objects to work with. So next thing is going to be our player class. And I don't think I have actually anything in the presentation for this. I was planning on just programming this. Okay, sorry, I just had to take a drink there. I was getting a little dry. But yeah, we can just go ahead and do this on the fly. So next thing we want to create a class called player.java. Yep. And this is going to implement game object and is going to be our player. So public class player implements game object. Oops. So implements is actually what you use for interfaces. Instead of extend, which you would normally use to extend a class that's not an interface, we use the word implements. And right now, our player, I think right now we're just going to make it a rectangle. So anyway, our constructor, well, we have a constructor, I guess, yeah. We're going to have, what other method we're going to have? We need to, in fact, this is what happens right now. If I was to compile this, since we're implementing game object, it says we are missing, player is not abstract and does not override abstract method update. So if we did a public abstract class, which is just something cool you can do in Java, then it doesn't need to implement all of the interface voids, or methods, I mean. But if you don't need to implement them, of course we do want to implement these. So all you really need to do is copy those over to here. And add bodies to the different things, and then it should compile. All right, cool. So these are the 3 methods we're going to have in player. We might have one more at some point, but this is what we're going to have so far. So as I said, player is just going to be a rectangle for now, and I'll just create a field for that. And if we want to move around the player, we want to have some sort of field that represents the speed of the player, some arbitrary number that we can deal with later. And I'm just going to set that equal to 10, and we'll see how fast that is once we've got that implemented. And the constructor for player, we're just going to do player rectangle equals new rectangle, and whatever size you want the rectangle to be, we can do, I don't know, 32, 16. Oh, that's the x and y. Well, yeah, we'll set that. Okay, so x, y, width, and height. So width will make 16, height will make 32. And that's it. So we've got a rectangle, and actually there's one more thing we need to do. In order to make it so we can actually render this rectangle for now, we want to generate graphics. Remember we made that method before? So we do rectangle.generate, how do I spell generate? Generate graphics. And generate graphics takes, does it take just one field? Rectangle. Border width and color. So border width will make 3, or yeah, we'll make it 3, and then the color, we'll just make it. What colors can I use? Let's just pick a color. Pick a color, any color. 0xFF 00FF. We'll do that. What's that color? FF00FF. All right. Oh, I don't really want that, do I? That was why I remembered that color, because it was the color that was nothing. So we'll do 0xFF FF, or just 0xFF 00FF90. I'll do that, whatever. Just any random color. You can actually just enter any random number, and you'll probably work here. And then render, it's just going to do renderer dot render rectangle, and we're just going to go over to render handler here and copy over the render rectangle arguments so we can easily add those. It's something very easy to do in Java, so render rectangle, and then just paste all that, and then we know exactly what we need to pass in. So we have the rectangle, which is player rectangle. We have X zoom, which is being passed in. We have Y zoom that's also being passed in. And that's all we need for render right now. And update, we'll figure out in just a second, but I want to go ahead and first of all see if this works. So let's go ahead and go to game. And when we're loading objects, we want to go ahead and set the size of objects to 1, because we're now going to have one object in our objects array. And then we're going to go ahead and create a new player. And you know what? I'm thinking we probably want a field for this. So private player. I'm sure we'll use that at some point. So we'll do player equals new player, and we'll pass in, or does it take anything? I don't think it does. Nope, just the constructor is just empty. So there we go. And now what we can do is set objects of index 0 equal to player. You might say, well, don't we have to cast that? Nope, because player is a type of game object. So once we put it in here, it'll automatically be cast to game object since this is a game object array. So yeah, there we go. Now if we were to go ahead and run this now, we have a little rectangle here. And, you know, we can't move it around right now because we, well, I don't know, we just can't. Because we, what am I trying to say? Because we don't have anything to move it around with. But it renders, so that's right now that's working, and it's working really cool with game object and stuff. Okay. Sorry, I have a little bit of a dry throat. Anyway, I'm going to quickly use part of my presentation to teach you about keyboard input. And for this, we're just going to look at the Java doc, because this is just purely a Java thing. Why not just use the Java doc for this? So, the Java doc gives us 3 methods in a key listener. And we need to implement key listener, which is also an interface, and override these 3 methods to have things happen. And you can add these to any frame. That's pretty much all you need to know about key listener. So, yeah, this is a purely Java thing, and I don't really like teaching you guys stuff that you can easily learn with a Google search. So that's kind of like whatever the purely just Java stuff is, other than like interfaces and stuff, because that stuff is pretty on hierarchy. That's can go between languages. So anyway, we are going to create a class called keyboard listener. We're going to create this in our workspace. All right, so keyboard listener.java. And I know you're probably thinking, why aren't you going to get to that bonus? I will at some point. I just need some stuff to test it first. And I wanted to give you something that would you could be able to just challenge yourself if anybody wanted to challenge. So I'm just going to go ahead and do the imports first, which I normally don't do, but I know exactly what the imports are going to be. We have, if we look at that Java doc, we have the key listener, right? So that's just, in fact, I think I got that. Yeah, java.auth.keyListener. Wow, I just kind of know my imports now. So we have java.auth.keyListener, and then we have, there's a few more. So we have key event, which we need to import as well. So let's just do import java.auth.event.key event. And there's actually something else I want to do as well. And I think I have this on the PowerPoint as well. Let's see. No, that's the next thing we're going to do. But, okay. So, what I also want to do as well is we want to know when we are actually like focused in on the window, because we don't want key presses to happen when the player is not actually in the window. So there's something we can use called focus listener to do that as well. So we're just going to do import java.auth.event.focus listener and import java.auth.event.focus event. It's kind of the same sort of thing as key listener. Okay, so now finally for the actual class declaration. This is going to be public class keyboard listener implements implemented. At one point it implemented. No, implements key listener And you can actually do two implementations here because we want to implement key listener and we also want to implement a focus listener. So I did all of that in one line just with a comma. So that's one thing Java's really cool at doing. And then if we try to compile this, it's a keyboard listener is not abstract and does not override abstract method key released key events. There's a bunch of methods we need to create, and I'm just going to put these all in here. So public void, we have key pressed, we have to override, and that takes key event event. I'm just going to call that event. So public void key released is another method we have to override, and that takes a key event as well. And then we have public void. There's also a key typed, which is kind of like a press and release event, which we're not actually going to use. So I'm actually just going to put the brackets here and leave that blank, but we have to override it. Public void focus gained. We're going to go into the focus listener now. And yeah, I'm not explaining really all of these because it's just Java stuff. Focus gained. We're not going to worry about this either. We just need to figure out when focus is lost. And I'll tell you why in a second. So public void focus lost is another focus event. And this is one we're actually going to have a body for. In fact, anything that we're not using, I'm going to put at the very end. So I'm going to copy this up here. Just for kind of structuring purposes. And then, yeah, that's all the stuff we have to override. So now if we compile this, key released, I spelled release wrong, didn't I? Key release, what is going on here? I'm just gonna put that in there and see what happens. Oh, lowercase k, obviously, yeah. And over here as well, probably. All right, there we go. So all that's implemented into our keyboard listener now. So now we want to actually do stuff here. So what we're going to do is we're just going to keep an array of the keys that we need. And the keys that we're probably going to have to use is the length of kind of a normal keyboard. What we're going to do is we're actually going to create a Boolean array of size 120. And there's like 120 keys that we're going to worry about. And these keys are just different key IDs that we'll just figure out. So that's what we're going to do. And if I go ahead and just do system.out.println, and then you can do event.getKeyCode. You don't have to do this, by the way. That's why I'm doing this pretty fast. But yeah, I'm going to go ahead and quickly... This is something you do have to do. I'm going to go ahead and actually implement this keyboard listener in our game. We're going to do this up where we're creating objects, I guess. It's kind of the same sort of thing. So private keyboard listener. We're just going to call this key listener equals new keyboard listener. And that should compile. Yep. All right. And then all we're going to do is we have to actually attach this to our frame or our canvas. And we do this at the very bottom of game here. After we load objects, we're going to add listeners. And we're just going to add these to the canvas. The canvas object that we have in Java up here. Canvas.add key listener. Key listener. Oh, by the way, the reason why I'm not actually declaring the key listener down here is because we don't need any other arguments. We can just declare it easily enough in the field. Instantiate is what I meant to say. I'll say what I'm about to say because that's pretty confusing. We don't have to instantiate it down here because we can easily enough just instantiate it when we're declaring it in our field. So canvas.add focus listener as well. That's another method in Canvas. And since key listener serves both those purposes, we can just add both of those. So now, if I run this game, you might remember I printed the lines of the keyboard listener. Now if I press some keys here, the key event code will get printed out, and most of them are between 120, unless you press a really weird key, like, what key was that? Oh, that was a, okay, so I guess you can make whatever size you want, as long as it's within reason. Like, all the ones I'm going to be using is WASD. That's what I'm pressing, and those are all within that boundary, and so is the arrow keys, which I'm also going to be using. I think that was the only one that I could find that was above, and that's the Oh my god, why can't I think of it? That's an apostrophe. It's an apostrophe that I couldn't think it was apostrophe. This is the numpad keys, so those are all within 120 as well. So yeah. Now we can go into keyboard listener and just go. We're just gonna make sure that we're within the oh my god, the range here. So if event, we'll do this. We'll do int keycode equals event.get keycode. All right. Now if keycode is less than or equal to wait, not less than, just less than keys.length. Then we're gonna do keys event.get keycode, or actually we just have it there. Keys of keycode is gonna be equal to true. And that we don't need any brackets for that. We don't need a body because all we have is one statement. So we get the keycode, and then we check to make sure within the boundaries of our keys array, and we set that to true. And it's pretty simple for key released. Int keycode equals event.get keycode again. And if keycode is less than keys.length, keys of keycode is going to be equal to false. Same sort of thing. And that should compile. All right. Now you might be wondering, so why do we have focus lost here? Well, what's going to happen is if we were to go ahead and press something and then tab out of our window, that key is going to stay pressed, which is kind of what happens when you're playing a game and you go forward and then you lose focus and your guy continues going forward. That's because they decided not to do this. All we're going to do is if focus is lost, we're going to go through all of the keys in our keys array. And we're just going to set them to false. So keys of I is going to be equal to false. And that's all focus loss is going to do, and that's the only reason we're making this, we're doubling this as a focus listener. And there's a few more things I want to add here. So we want to, in order to make this simpler, for key listener, I'm just going to have a few methods that to figure out what direction our character is going in. So this is going to be booleans up, boolean up, public boolean down, public boolean left, public boolean right, and yeah, that's it. So all it's going to do is return true if we want to go up, down, left, or right. So this is going to return keys of, well, I want W to be up. So what we can do actually is go into key listener and then key event. And one cool thing about key event is it has a bunch of static, I guess static fields, which you can use for identification purposes. And it's VK underscore whatever key you want. So if I go ahead and search VK underscore W, this represents the key code for going up, or sorry, for W, for the key W. So we can do, it returns keys of key event dot VK underscore W. Okay, and there's also a VK underscore up, and that's the non-numpad up arrow key. So return keys of that, or also we're going to do an or here, keys of key event dot VK underscore up. Okay, so that's pretty cool. We did that all in one line because we don't need an if statement, since this returns a boolean if either of these are true, since we're using that or operator. Now down, it's going to be pretty simple. It's going to return VK underscore S or VK underscore down. They're all pretty simple, to be honest with you. And then we go to left, and left is going to be VK underscore A or VK underscore left. These are in all caps because static fields are usually in all caps when it comes to these kind of things, when they're identifiers for specific IDs. VK underscore D is right, like the WSD, and VK underscore right. So pretty simple. So we've created something that we can easily figure out what keys are being pressed and move our character accordingly. So what we're going to do now is I'm going to go ahead and explain to you how useful game objects are and how useful getters and setters are. So right now we have a key listener in here. What I'm going to do is create not a setter, but a getter for this. So we're going to do public void or public keyboard listener get key listener. And this is just going to return key listener. All right. So now you might remember in game object we have an update method which gives us the pointer to our game, and what we can do is in player we can just get the key listener from this, right? So we can do an update keyboard listener key listener equals game.get. What do I have it set? What do I have it set to? Get key listener. So that's pretty cool. Now we have the key listener from our game just in the update method. And of course, the update method is going to figure out where we want to go. So pretty much, very simple. If key listener dot up, then we want to make the character move up. And to do that, we just take the player rectangle and then dot y, and we minus that by the speed, which we defined up here. That's where that arbitrary thing comes in. And we're not going to do an else if, because if someone presses like the up and down key at the same time, we want them to kind of stay in the same spot. So if key listener dot down player rectangle dot y plus equals speed, if key listener dot left player rectangle dot x minus equals speed, if key listener dot right player rectangle dot x plus equals speed. All right, there we go. So now, actually, if we run this game, and if I use the arrow keys, so WASD, to move around, our player will move around, and this brings out a new error, right? I guess it's not really an error. The reason that's happening is because we're not overriding any of the pixels from the previous frame. But because the map is rendered every frame, I can move around here fine, but then when I go over here, it's like, whoa. This is pretty easy to fix, actually. I just never thought we would need to, or never thought it was really worth it. But why don't we go ahead and actually do that right now, just for the purposes of how easy this is. So if we go to render handler, we can go to, I guess, is it? Yes. Yeah, we can just create another method here called public void clear. And all it's going to do is loop through the whole pixels array and set it to 0, which is neat color black. And then all we have to do is in game.java, in our renderer, your after set dispose by strategy.show and renderer.clear. Oops. Alright. And then we can compile and run. And now the render is going to clear every frame, so we can move around and we don't have a trail behind us. So yeah, this is pretty cool. There's a few things now that we're going to work on, and that is the fact that the player does not move with the camera. I kind of want the player to move around with the camera, and so pretty much everything moves around where the camera is anyway, so we want the player to just stay in the middle of the camera. So this is also a relatively simple thing to do. All we're going to do is add another method into player. Remember I said there would be one more method we deal with here, and that's going to be called update camera, and this takes a camera, and all this is going to do is set camera.x equal to player rectangle.x minus the width of the camera divided by 2. Okay, so the camera is going to be offset by a width, so the player stays in the middle of the camera the whole time. And the reason why we're not offsetting the player instead of offsetting the camera is because we're dealing with the player speed and directions and stuff in the player class, so we want the camera to change accordingly. And all we need to do in update is actually just call, at the very end here, update camera with game.getRenderer Get camera. So you can see how useful having an instance of game is. Do we have a get renderer? Thought we had a get renderer. Okay, that's fine. Very easy. Public render handler get renderer. Then return renderer. That's just in-game.java. Oh, still having problems. Cannot find symbol in player. Update camera. That's why. Just typo. Alright. So now the camera should update around the player, and there we go. So we can move our player around, and the camera will always offset depending on where the player is, so that the player is constantly in the middle of the camera. So now you might be like, oh, that's why he went until this point to give us the bonus. Now we can move around our camera and truly make sure that our fill tile works, right? So finally, let's go back to map.java and uncomment this stuff and get back to what the bonus is for this episode. So I told you this is gonna be probably gonna be a pretty difficult bonus. You might think it's easy, but then when you start doing stuff, it'll get harder. And if for some reason you didn't do this and you didn't experience the difficulties with this, I'll show you why exactly it's difficult. So let's do what the obvious thing to do is here. Well, not necessarily obvious, but the easiest thing to do is here, and that's just to loop through every tile, right? So we do y is equal to 0, y is less than camera.height, and then y plus equals the y increment, which we've defined to be the specific width of a tile. I guess I could call that tile width. Might be an easier thing to call it. Let's do that. Tile height, I mean. This is tile height. Tile width. Those are easier variable names to understand. And I think actually a lot of you, if you had that previously, you might have understood this more. And then x plus equals tile width. And then what we do is we just render each tile, right? So tile set dot render tile, and the tile ID was fill tile ID. Yeah, and then we're passing in the renderer. Let me just go to tiles. I know it passes in a render. I forget what the other stuff is. So tiles.render tile method is copy all this down. Well, let's copy that down. And then go to map. Alright, so that takes the renderer, it takes the x position. Now the x position is going to be tile, it's going to be x, and the y position is going to be y. The x zoom is going to be passed in, and the y zoom is going to be passed in. Let's compile that. Oh, yeah, semicolon. Cannot find symbol. Oh, because I renamed it to tile width and tile height. So we're going to replace x increment with tile width. Replace. Replace y increment with tile height. Replace. Okay. Oh, more errors. Fill tile ID cannot find symbol. What's that? That's fill tile ID. File tile ID. Oh my gosh. All right. There we go. So that's the obvious thing you're doing. Well, not obvious, but you know what I mean. And now if we render, as you can see, the whole map renders from in that boundary. Now here's the weird thing. It's only rendering for one camera width, right? But because of the way we have map working, it's only rendering for that camera width in the center here, right? It's not actually like filling the entire camera. So then you might learn, okay, well now we have to do this. We just have to instead make this render depending on where the camera is, and that is the next adventure we have going on here. So y equals 0, y is less than camera.height, and actually what we want to do is y is equal to camera.y, y is less than camera.y plus camera.height, x is equal to camera.x, x is less than camera.width plus camera dot, or oops, I'll do it the way I did out there. Camera dot x plus camera dot width. All right, so now if we run this again, oh, I have a bunch of things open here. Let me close this out first. as you can see, it fills with the entire map. But, oh, now this is interesting, isn't it? Because as you're moving your guy around, like, it doesn't actually move. It almost looks like just like a static background because of the way we're doing this. We want the background to move with the map, right? So, yes. Now there are multiple ways we can get around doing this. We could instead just render every single tile in a specific bounded map. But here's the problem with that. Right now, I'm not bounding the map, right? I'm making it so that we can place a tile wherever we want it to be, and it'll actually be there. And that's something that most game engines don't do as far as game engines at this level, but it's something really cool and advanced that I really wanted to do in this game engine and this tutorial series. So, yeah, we can't just like say how much we want it to render. Instead, we have to offset it by using mod, by figuring out how much in we are and how much out we are. And now that for some people, your heads might be exploding at this point. Just watch what I do, and once I do it, you might actually understand what I'm doing here. So, we're going to take camera.y, and we're going to... So I did something a lot different in my original code, but we're going to try something else out here. And do camera.y mod tile... Hold on. Camera.y plus camera.y mod, which is the % symbol, tile height, and then camera.x plus camera.x mod tile width. And I actually haven't tested this before. We'll see if this works. Let's close out of this first and run. Well, does the okay, so I think it's doing the opposite of what I wanted to do. So we're just gonna go ahead and go down here and oops, I'm gonna do minus. I'm doing this on the fly, so all right, so there we go. Now we are filling our entire map just by like modding. So I'll explain two things. First of all, why this is happening, and second, what exactly is going on here. So if you've never used mod before, mod will pretty much divide whatever number we're talking about here. So let me go back here. Mod is going to divide camera.x by tile width, but it's not going to give us that. It's going to give us the remainder. So for example, let's say tile x or camera.x is 35 and we're modding by 32. It's going to divide by 32. And then what's going to be given back isn't this, but instead this, the remainder. So 0.09375, okay? And that's how much we want to offset by. In this occurrence, it was a very low number, but yeah, that's what we want to offset by. But why this is happening is because we're offsetting, and we want to have just one tile of what's the word I'm thinking of? We want one tile of padding on each side. So all we're gonna do is camera.y minus 1 tile height and camera.x minus 1 tile width, and then subtract the mod as well. Compile that and check this out, see if that works. And there we go. We filled our entire map with this tile, and we did it in a very elegant way. And the cool thing about this is once we get into like SDKing and stuff like that, actually placing tiles and stuff like that, we can place them wherever we want, and it's dynamically updated. Our map is we have no boundaries to our map. And some of you that are very keen on understanding like the how this works, or I guess those of you that have done a lot of Java game programming before, I'm wondering, well, you realize what this is bad, right? Because array lists and stuff, and you just kind of render everything. You have no idea where the tiles are, and you have to loop through everything. Understand this. I'm not going to have that set up like this forever. We are actually going to have something cool called dynamic arrays, where what's on the screen will be a part of a separate array than the entire map. Okay, that's all you need to know. So we'll be able to keep the dynamic arrays, or we'll be able to keep the freedom of placing tiles wherever we want with having dynamic arrays. So, yeah, there you go. So we got a moving player and stuff, and we got a map working here. So, pretty awesome. And that's really, I guess, it for this episode, I think. Let me think of a challenge I could possibly give you. There's one more thing we're gonna do, and that's gonna lead to the challenge for this episode. Let's go back to the PowerPoint quickly, and I'm just gonna show you the mouse listener. So we have mouse listener and mouse motion listener. Those are two things we are going to import. And let me just go ahead and mouse. Okay. Now what we're gonna do is we're going to create a new class quickly to be our mouse listener. So new class, call this mouse event listener dot java, and let's open this up. And this is going to be, it's going to import java.auth.event.mouse event or mouse listener. It's also going to import mouse event as well, and also java.auth.event.mouse motion listener. Okay, very simple. Now public class mouse event listener implements mouse listener and mouse motion listener. Just two things we're going to use, and there's just a few methods we're going to need. Excuse me. All right. We're just going to get a constructor first, and this is not going to be like a game object. And just a hint for the challenge, we're going to take a game. So mouse event listener constructor does take a game instance, and this dot game is going to be equal to game. Go ahead and do normal bracketing, not C style here, and public void mouse clicked mouse event public void mouse dragged mouse event. These are just a bunch of methods we have to override, and they're pretty self-explanatory to their purpose. Public void mouse entered, so if the mouse entered whatever this listener is attached to, which will be attached to the canvas. Public void, oh my gosh, mouse exited. Mouse event. Whew, public void mouse moved. Mouse event. Public void mouse pressed. Mouse event. And then finally, public void mouse released mouse event called event. So, yep, mouse clicked if the mouse is clicked, mouse dragged if the mouse is dragged across the window, like if you click and move it. Mouse entered if the mouse entered the region, mouse exited if the mouse exited the region. Mouse moved if the mouse is just moved, not dragged but moved. Mouse pressed if we just click, and mouse released, click. And mouse clicked means both a press and a release. Kind of like how key listener, key typed means both pressed and released. So now we're going to go back to game and go up here, private mouse event listener, mouse listener equals new mouse event listener. All right, we're going to go ahead and just create a getter for this. Public mouse event listener, get mouse listener, and this just returns mouse listener. Oh, and we need to pass in this for the mouse event listener. And there you go. One more thing we have to do is down here we have to do canvas.add mouse listener, and canvas.add mouse motion listener, mouse listener. And that's it. Now we have a mouse listener. So your challenge for next time. Yeah, sorry that I did that pretty fast. If you want, you can go back and pause to figure out exactly what I did. I just want to end this episode and give you your challenge. So your challenge for next time is when the mouse is pressed, I want you to place a tile at the specific location that mouse is pressed. And the only thing I'm going to give you here is if we go ahead and look up mouse event .html. Just on the Java docs. You have a few methods here that you can use. We have which button is being pressed. Button 1 is the one you probably want to use. Well, you can use whatever you want. You can also use, I think this is right click and this is middle, but you can figure that out. And mouse event has get X and get Y. And you can also figure out what a get X on screen or get Y on screen is. But yeah, those are the methods. I just want you to figure out from these methods I'm giving you, from the fact that you've passed in game as a field, I want you to figure out how you place a tile where the mouse is pressed and whatever tile ID you want. But yeah, that is your challenge for next time. So anyway, guys, that is it for this lesson 8 of our Java game programming series. That is your challenge for next time, should you choose to accept it. Thank you for watching, and I'll see you next time.